whatever development is happening today, it has to be with such an angle that our sustainability is ensured and all those reserves are sustained for many you know decades, many centuries. So this is the whole perspective of sustainable development. So the sustainability development is holding its base on three pillars. First is environment. As we all know, we have to conserve the resources, we have to protect the environment, and at the same time biodiversity also. Means आज हम for example cement बनाते हैं. As we all know, JP is one of the very big player in cement, so is other many players. Cement को बनाने में we need to have that natural resource as limestone. Limestone की mines होती हैं, but it's a natural resource, so it also has a shelf life. We cannot keep on extracting limestone till eternity. One fine day, the entire reserve will come to zero. So what that mean? Shall we stop constructing today, or maybe after maybe couple of 100 years down the line, will there not be any cement? There will be cement, but we need to ensure that whatever extraction of such minerals, whether it is limestone, whether it is iron ore, whether it is aluminum ore, whether it is copper ore, whether it is zinc, whatever we are, or manganese, whatever ore we are extracting today, it has to have the very high degree of consideration that it can sustain for many decades, many centuries. So we need to protect the environment. Second point is society. So what does society need? Energy and food security, health services, and security of the social equity. So we have to keep this social angle also in our mind. Third is economy. आज हम जो भी काम कर रहे हैं, it has to be viable from the economic point of view. So the cost efficiency has to be looked into. So these are the basic three pillars. And what does green and sustainable development brings? Improvement of life, environmental protection, energy conservation, waste reduction and cycling, जिस पे मैं बात करूंगा, efficient use of natural resources and better operational performance. I will just give a couple of seconds to all the 6 points. Improved quality of life. If you had gone to a jungle versus if you have gone to a city like Delhi or Noida, which are considered as highly polluted cities in the world, you will find a sea difference, huge difference between the two surroundings. In when the quality of life is improved, you have better breathing, better ambience, good amount of light and air and everything. So you feel naturally protected. Whereas in such type of stressed cities like what I have mentioned, or maybe there may be a couple of many cities like this, you do not have good quality of life. It is like a compressed, it's like a challenged life. So if the planners had taken all that parameters into consideration while developing such cities, or construction of so many industries, possibly we could have reduced the pollutions to a great extent. Second point is protection of the environment. If you had happened to if you have ever happened to visit area which is around cement industry or steel industry or maybe oil refinery, you will have a lot of suffocation, a lot of the quality of air or the breathability is greatly challenged. So the protection is not, the environment is not protected to the fullest. So we need to take due efforts towards that. What is energy conservation? Today we are extracting the fossil fuels, that is coal, and we are generating artificial energy. But as I mentioned earlier, every single natural resource has a limited life. It cannot keep on generating till eternity. One fine day it will be completely exhausted. So before it gets exhausted, we need to develop such technologies. We need to have that kind of management wherein we can conserve these fossil fuels or the natural resources. When we talk of energy, why not to shift for solar power plants? Why not to encourage the wind power, so that a great percentage of fossil fuel energy is replaced. Nowadays, central government as well as state governments are encouraging these energy sources, and with very proud we can say that Madhya Pradesh, where we are sitting right now, has become at Riva they have got the world's largest solar power plant, which was inaugurated by our Prime Minister Modi ji about 2 months back. Online, it was an online inauguration. So the Riva has got the facility of world's largest solar power plant. So we need to develop similar kind of capacities across India so that we can conserve the energy. Then we talk of waste reduction and recycling. इस पे मैं बात करूंगा. A lot of construction and demolition waste is being generated, but we do not know how to recycle and how to make best use of it. So we need to work on that. Efficient use of natural resources and better operational performance. Today, most of the industries, primarily in the government sector, they have become defunct. Why? Because they never upgraded themselves, whether technically or operationally, with the changing demands, changing needs. So they have become defunct, or even if they are working right now, the operational performance is challenged because they do not they have not imbibed the right technologies to improve the efficiencies of their manpower, of their resources, of their production. So we need to keep on developing, we need to keep on imbibing the new technologies so that operational performance can be better as compared to the existing ones. सस्टेनेबिलिटी इज ऑलवेज लोकल. इसका मतलब क्या हुआ कि आज यदि मैं कोई कंस्ट्रक्शन कर रहा हूं, फॉर एग्जांपल इफ आई एम कंस्ट्रक्टिंग ए हाउस इन गुना, it will require cement, steel, sand, brick, wood, that is plywood or mica, or maybe some other interior items. If suppose a house is being constructed in Guna and the materials are being brought from Chennai, Calcutta, Noida, Gurgaon, or maybe from all the far flung areas which are 1000 to 1500 kilometers from that place, will that construction be a green structure? Will it be viable? Will it be sustainable? No. The moment we import the design or the technology or the product or the materials, the environmental impact is increased manifold. Because just imagine, यदि मैं किसी एक आइटम को लाने में 500 या 1000 किलोमीटर का ट्रेवल हो रहा है, obviously one truck load is coming from 1000 kilometers. Just imagine the quantum of diesel that has gone to transport that material from one place to the another, and the quantum of the gases which has gone into the atmosphere. So it will no longer be a green building. We have to be extremely local. Now, let us come to the green and sustainable building. So it has 7-8 major parameters, and we have got good credit agencies which certify a building to be a green building. I have a very good fortune of visiting JP University Guna, because previously I was working with this organization only, and I used to visit that particular campus as a faculty. So for the new batches of civil engineering students, I found that the industry that particular college has been beautifully built and constructed. A lot of open areas, green lush parks and open surroundings within that campus. So it looks like a very green and sustainable building. But apart from that, there are a couple of parameters which we need to keep in mind while designing a green building. So we start with the electricity, as I mentioned. Instead of artificial electricity, that is fossil fuel based electricity or thermal power based electricity, we must get water induced energy, that is हाइडल पावर प्लांट से हम एनर्जी ले सकते हैं, हम सोलर पावर प्लांट से एनर्जी ले सकते हैं, हम विंड पावर से एनर्जी ले सकते हैं, और पार्टली हम रिप्लेस कर सकते हैं टू मेक आवर बिल्डिंग ग्रीन. JP is considered as one of the largest player in hydel power projects. So in India as well as in Bhutan also, they have done some wonderful and momentous projects in hydel power. Second point, generate all its electricity on site as far as possible. For example, if a building happens to be a college campus, there are a lot of roofs, large roofs are available. Why not to put solar plants on the roofs and generate good amount of electricity, or at least so that it can partially replace the overall requirement of the campus. So that can be looked into. Third point, पानी का रिक्वायरमेंट है, क्या मैं पानी के जो भी रिक्वायरमेंट है मेरे एरिया में, मेरे प्रोजेक्ट में, मेरे कैंपस में, क्या मैं उस पानी की कंप्लीट रिक्वायरमेंट को अपने इंटरनल सोर्सेज से कंप्लीट कर सकता हूं, और shall I have to depend on the municipal supplies? इसका मतलब क्या हुआ? If I am designing a project में obviously there will be a lot of water demands post occupation. Can we plan the design of the building or the apartment or that particular project in such a way कि अब जितना भी waste water generate हो रहा है उसको हम recycle करके it can be put into good use in watering or gardening or for that matter cleaning of the your four wheelers. Secondly, can we have that water harvesting has been planned or not? Rain water harvesting, पानी गिरता है बट हमारा एक्सपीरियंस कहता है तो 70 to 80% पानी जो होता है वो रन ऑफ हो जाता है, बिकॉज वी हैव कंप्लीटली कॉन्क्रीटाइज अवर स्पेसेस जहां हम रहते हैं. हम घर के बाहर रहते हैं, घर के बाहर हम देखते हैं कॉन्क्रीट रोड बन गई है. कॉन्क्रीट रोड के बाद दोनों तरफ जो पहले एक पैच हुआ करता था सॉइल का, वो खत्म कर दिया गया है. Even if you go to the gardens, even 50 to 60% of the gardens have been converted or covered with thick concrete beds. So it's very, very ugly picture from a civil engineering point of view. We need to have good amount of soft soils within our ambient spaces so that the rainwater percolates down in the ground and recharges the groundwater table. So this is all about rainwater harvesting. Recycle and reuse of its waste on site and least burden on the environment. जब भी कोई प्रोजेक्ट बनता है, a lot of raw material is generated. Okay, so shall we just throw this raw material or the building waste material just like that, or shall we have some plan in place so that it can be used either in the same project as a filling material or at a place where it is required, or it can be just put another burden to the environment and the municipal authorities. So we need to give a very thoughtful consideration on recycling and reusing of the waste which is generated on the site. Fifth point is the waste material management is very, very important. For example, after your construction or the built environment has completed its life cycle. Okay, after the life cycle has been completed, it will obviously put to demolition either by the authorities or by the occupants themselves. After the demolition, huge amount of debris and construction waste material is going to generate it. Now, what is the plan to transport? What is the plan to make use of it? And what is the plan to segregate? So there are all so many parameters that come into picture while designing construction and demolition waste management. So we need to have a very thoughtful consideration on this aspect as well, जिस पे मैं आने वाली स्लाइड पे बात करूंगा. फिर then there is a point कि हम अपने प्रोजेक्ट में कितना ग्रीन मटेरियल यूज कर रहे हैं. अब ग्रीन मटेरियल क्या क्या होता है? Let us start with cement is a primary element for any building. सीमेंट को यदि मैं ऑर्डिनरी कोटेड सीमेंट से इस्तेमाल करता हूं तो ऑब्वियसली विल नॉट हैव ग्रीन क्रेडिट पॉइंट्स, बट इफ यू आर शिफ्टिंग और स्विचिंग टू ब्लेंडेड सीमेंट्स, obviously I will have some more green rating points. अब what is blended cement? As we all know that OPC के मुकाबले यदि उसमें मैं 35% तक रिप्लेस करता हूं फ्लाई ऐश को, तो इट बिकम्स पोर्टलैंड पोज़ोलाना सीमेंट. OPC में यदि मैं अप टू 65% तक स्लैग जो कि स्टील इंडस्ट्री का वेस्ट प्रोडक्ट है उसको इस्तेमाल करता हूं तो इट बिकम्स पोर्टलैंड स्लैग सीमेंट. सो ब्यूरो ऑफ इंडियन स्टैंडर्ड्स has given provision that instead of OPC, if we switch to Portland pozzolana cement or Portland slag cement, so in that way not only we are ensuring that waste material from thermal power plant, that is fly ash, and waste material from steel plants, that is slag, is being used in very good quantity, and still we are getting and after mixing it with cement, we get a very good quality product that is not only long lasting, durable, but at the same time qualifying in the green building material. So switch from OPC to blended cement, switch from red bricks to autoclave aerated concrete blocks or your fly ash bricks, switch from river sand to your M grade sand, manufactured sand. Switch from reduce the quantum of steel in your structures as far as possible. So these are all parameters that we have to put into consideration while designing a green building. And as already mentioned, reuse the rainwater on the site. So for that, we need to have a very good, rainwater harvesting in place. There are three major agencies which certify green buildings. One is Indian Green Building Council, IGBC, headquartered as Hyderabad. Second one is GRAHA. GRAHA stands for Green Rating for Integrated Habitat Assessment. Okay, so that is the second agency. And third, which is a US-based Green Building Council, LEED, which stands for Leadership in Energy and Environmental Design. So these are there are a couple of more agencies are also in place. So these are the major agencies which can be approached while seeking a green building assessment and green building rating. Now this is a very interesting slide. So that is primarily meant for green product certification. Up till now I have spoken about the green building projects, but there are manufacturers who are attempting for green building certification. So for that, the manufacturer has to keep these 8 major points into mind and in their design system. Then only they will get the due number of green credit rating points that will enable their product as green product. So I'll start with product design, the very first one. तो प्रोडक्ट डिजाइन क्या होता है कि हम किसी प्रोडक्ट को बनाने जा रहे हैं जिसको मैं अटेम्प्ट कर रहा हूं कि वो ग्रीन बन जाए या ग्रीन प्रोडक्ट बन जाए, उसमें मैं डिजाइन स्टेज पर ही सारे पैरामीटर्स को कंसीडर करूंगा, क्योंकि मुझे मालूम है कि ग्रीन प्रोडक्ट में क्या क्या चीजों का समावेश होना चाहिए, तो डिजाइन स्टेज पर ही वो सारी चीजें मेरी आ जाएंगी. तो विल स्टार्ट विद द डिजाइन. सेकंड पॉइंट इज प्रोडक्ट परफॉर्मेंस. सेकंड पॉइंट में क्या बहुत इंपॉर्टेंट होता है कि आज मैंने प्रोडक्ट बना लिया, इसका परफॉर्मेंस किस एरिया में होगा, इसका यूटिलाइजेशन किस फील्ड में होगा, क्या वो फील्ड या वो एरिया ऑफ यूसेज इज आल्सो इन कंफॉर्मिटी विद ग्रीन टेक्नोलॉजी. दिस इज व्हाट वी हैव टू थिंक. तो वो भी हमको ग्रीन पॉइंट्स देने में मदद करेगा. थर्ड, अनदर इंपॉर्टेंट पॉइंट, उस प्रोडक्ट को बनाने में मैं रॉ मटेरियल्स कौन से इस्तेमाल कर रहा हूँ. फॉर एग्जाम्पल, मैं एक सर्टेन आइटम को बनाने के प्रयास कर रहा हूँ और उसको मैं अटेम्प्ट कर रहा हूँ कि इट शुड बी रेटेड एज ग्रीन, बट उसमें इस्तेमाल होने वाले जो रॉ मटेरियल है या उसमें इस्तेमाल होने वाले जो इंग्रेडिएंट्स हैं वो सभी नॉन ग्रीन हैं, देन योर प्रोडक्ट विल नॉट गेट ड्यू नंबर ऑफ ग्रीन रेटिंग पॉइंट्स. तो रॉ मटेरियल का भी ग्रीन होना बहुत जरूरी है, रॉ मटेरियल्स का लोकली अवेलेबल होना बहुत जरूरी है, और सबसे इंपॉर्टेंट है क्या जो रॉ मटेरियल आप इस्तेमाल करने जा रहे हैं वो किसी इंडस्ट्री का यदि वेस्ट प्रोडक्ट है, then your rating point will be even higher. For example, यदि मैं सीमेंट को मैं अटेम्प्ट कर रहा हूं ग्रीन बनाने के लिए, तो यदि मैं प्योर ओपीसी की बात करूंगा, it will never be given a green material tag. बट उसमें यदि मैं कुछ फ्लाई ऐश मिला लूं, मैं उसमें कुछ स्लैग मिला लूं, या मैं कुछ ऐसा एक वेस्ट आइटम जो किसी इंडस्ट्री का वो मिला लूं, तो वो मैं अपने प्रोडक्ट को ग्रीन कर सकता हूं. क्यों? क्योंकि मैं दो तरीके से एनवायरमेंट को प्रोटेक्ट करने की कोशिश कर रहा हूं, विच इज द बेसिक प्रोमाइस ऑफ ग्रीन प्रोडक्ट सर्टिफिकेशन. किस तरीके से? पहला, मैं एक इंडस्ट्री के जो वेस्ट मटेरियल है उसको रिड्यूस कर रहा हूं, और वो जो वेस्ट मटेरियल है वो किस तरीके से एनवायरमेंट को इम्पैक्ट करता है, किस तरीके से आपके सॉइल की फर्टिलिटी को खत्म करता है, किस तरीके से आपके इतने बड़े एरिया को अनऑक्यूपाइड बना देता है, यूजलेसनेस में कंट्रीब्यूट करता है. मैं उस रॉ मटेरियल को जो वेस्ट मटेरियल है के तौर पे इस्तेमाल करके और मैंने उस इंडस्ट्री को प्रोटेक्ट किया, साथ में अपने प्रोडक्ट पे भी सब्स्टिट्यूट कर दिया। दूसरा पॉइंट क्या होता है कि आप उसमें लोकल फैक्टर को भी एनकरेज कर रहे हैं कि किस तरीके से आपने उस मटेरियल को उस जगह से आपने मंगाया है विच इज एट ए वेरी स्मॉलर डिस्टेंस फ्रॉम द फ्रॉम योर मैन्युफैक्चरिंग फैसिलिटी। सपोज मैं एक एसी ब्लॉक के लिए अटेम्प्ट कर रहा हूं और उसको मुझे जो फ्लाई ऐश चाहिए है, उस फ्लाई ऐश को यदि मैं चेन्नई से मंगा के अपने प्रोडक्ट में इस्तेमाल करूंगा तो मेरे ग्रीन पॉइंट्स बहुत कम हो जाएंगे उस प्रोडक्ट के लिए। बट यदि मैं अपने एसी ब्लॉक के लिए फ्लाई ऐश जो कि कम से कम 75% तक कंट्रीब्यूट करता है, 75% तक फ्लाई ऐश को यदि मैं चेन्नई की जगह यदि मैं 100 किलोमीटर दूर किसी थर्मल पावर प्लांट से लेके आऊंगा तो we will have very great amount of or a higher number of green rating points. So this is raw material, which is very very significant in giving you this credit. Fourth point is manufacturing process. अब इसमें मुझे देखना है कि अब सब रॉ मटेरियल भी आ गया, आपके डिजाइन तैयार है, आपने प्रोडक्ट परफॉर्मेंस का एनालाइज कर लिया, आपका रॉ मटेरियल भी आपके आपके मैन्युफैक्चरिंग फैसिलिटी में आ गया। अब इस मैन्युफैक्चरिंग प्रोसेस जो स्टार्ट होगी, क्या उस प्रोडक्ट के बनने में बहुत सारी कार्बन डाइऑक्साइड या हैजार्डस गैसेस निकल रही हैं? दैट आल्सो वी हैव टू थिंक। सो वी हैव टू एंश्योर कि इस पूरी मैन्युफैक्चरिंग प्रोसेस में फ्यूल कंजम्पशन लीस्ट हो, मटेरियल तो लोकल है बट वो उस लोकल मटेरियल के प्रोसेस के दौरान भी कार्बन डाइऑक्साइड का या हैजार्डस गैसेस का एमिशन कम से कम हो। तो हमको और आप इस पूरी प्रोसेस में ऑब्वियसली यू विल रिक्वायर सर्टेन एनर्जी टू आप कोई भी प्लांट चलाते हैं तो यू नीड इलेक्ट्रिसिटी टू रन द मशीन्स, टू give a proper lighting arrangements to the ambience and all that. So आप इस पूरी फैसिलिटी में जो कि मैन्युफैक्चरिंग फैसिलिटी है उसमें या आपने अपनी मशीन्स को रन करने में क्या इलेक्ट्रिसिटी यूज की है, क्या आपने फॉसिल फ्यूल्स का यूज किया है, या आपने उसमें से कुछ पार्शियल लाइट को या पार्शियल एनर्जी को ग्रीन एनर्जी से सब्स्टिट्यूट किया है। व्हाट इज ग्रीन एनर्जी? एज आई मेंशन अर्लियर, वी हैव गॉट थ्री कैटेगरीज, मेजर कैटेगरीज ऑफ ग्रीन एनर्जी: विंड पावर, सोलर पावर और हाइडल पावर। हम क्या ग्रिड से उस एनर्जी को यूज कर रहे हैं जो कि थर्मल पावर प्लांट से आ रही है, या हम अपने प्लांट में ही कुछ ऐसा सिस्टम डेवलप कर रहे हैं कि जहां मेरी एनर्जी लार्ज एक्सटेंट तक सब्स्टिट्यूट हो रही है ग्रीन एनर्जी से। सो दिस इज व्हाट वी नीड टू फोकस। थर्ड इज एज आई से कि हम उसका वेस्ट मैनेजमेंट कैसे कर रहे हैं आफ्टर द प्रोडक्ट हैज कंप्लीटेड इट्स लाइफ साइकिल। इसका डिमोलिशन से लेके इसका उस यूज होने तक ये वेस्ट मैनेजमेंट मैंने कैसे किया है। लाइफ साइकिल अप्रोच, रॉ मटेरियल का एक्सट्रैक्शन से लेके, मैन्युफैक्चरिंग से लेके, ट्रांसपोर्टेशन से लेके उसका यूज क्या है, वेस्ट डिस्पोजल कैसा है। एंड देन सेवेंथ पॉइंट आता है कि आपने स्टुअर्डशिप कैसे ली, यानी कि आप प्रोडक्ट के एनवायरमेंटल इंपैक्ट को कम करने में आपने क्या रोल प्ले किया, सो दैट इट बिकम्स a lesson to the other industries also. So it is what is product stewardship or product leadership. ये बहुत बड़ा पैरामीटर बनता है। एंड एट विच इज लास्ट बट नॉट द लीस्ट, आपने इस पूरे प्रोडक्ट मैन्युफैक्चरिंग डिजाइन एंड एवरीथिंग, इस पूरी प्रोसेस में आपने नया क्या किया, व्हाट इज द इनोवेशन दैट यू हैव डन, व्हाट इज द न्यू टेक्निक यू हैव अडॉप्टेड। सो ये सारी चीजें होती हैं जो आज मेरे प्रोडक्ट को ग्रीन बनाने में और हायर रेटिंग देने में सफल करती है। एम्बॉडीड एनर्जी जो होती है किसी भी मटेरियल की, ये बहुत इंपॉर्टेंट पैरामीटर बनता है, इसको बहुत समझना जरूरी है कि हर प्रोडक्ट का एक एम्बॉडीड एनर्जी होती है। व्हाट इज एम्बॉडीड एनर्जी? यानी कि वो एनर्जी जो उस प्रोडक्ट को उसके माइनिंग स्टेज से लेके, मैन्युफैक्चरिंग प्रोसेस से लेके, ट्रांसपोर्टेशन होने से लेके फाइनल कस्टमर तक पहुंचाने तक जितनी एनर्जी लगी। फॉर एग्जाम्पल मैंने एक मोबाइल बनाया, तो मोबाइल बनाने में जो भी इंग्रेडिएंट्स होते हैं वो मैंने कहीं ना कहीं किसी माइन से लिया होगा, बन गया। उसके बाद मैन्युफैक्चरिंग के प्रोसेस में कितनी एनर्जी गई, फिर बाद में मैंने उस मोबाइल को ट्रांसपोर्ट करके अपने पास तक लाने में और फाइनली कस्टमर तक पहुंचाने में जो टोटल एनर्जी गई, दैट इज नोन एज एम्बॉडीड एनर्जी ऑफ दैट पर्टिकुलर मटेरियल। ओके, हाँ गाली जी। Oh, okay, fine, fine. I'll help this. Thanks. Yeah. Okay, so embodied energy of any building material is the sum total of the energy required in manufacturing process for that particular product from mining stage to manufacturing to transportation and finally up to the product delivery. So we need to consider that EBE for any given product, especially in building material, has to be on the lower side. I'll just show you one slide. Yeah, just have a look at that particular slide. As you can see, steel has EBE is as 32 megajoules per kg. 32. Cement has 6.7. As compared to that, if you just have a look at aluminum, which is on a staggering high as at 170, acrylic paints 61, plastic 90. So these are the building materials which are prominently used in any construction, which has very higher embodied energy. But we cannot, do away with that. Cement or steel has to be used. We cannot do away with that. But cement can be replaced with blended cement. So for OPC, if it is 6.7, for Portland slag and Portland pozzolana, it could be somewhere about 4. So let us go for blended cement. As you can see at the very top, fired clay brick, which is traditional red bricks, has 1.64. As compared to that, just have a look at that AAC block, which is about 3 times less, 0.6. Or for that matter, hollow CC blocks 0.4. So meaning thereby, we need to have a very clear understanding of EBE also. Before choosing one particular product for any application during the construction stage of a building, we have to have a very clear idea as to what is the total EBE of that particular product, and accordingly only we need to use it. So as I said, the 1 cubic meter of concrete requires about 2700 plus megajoules of energy. So why that? How come this amount has gone so high? Cement is 6.7, steel is 32 EBE, your brick is 1.64. So and AC block is 0.6. So our effort should be to use such materials which are on the lower side of EBE. Now, having said all these things, we have got some very smart, green, innovative solutions in cement and concrete material space. So I will just rush through some of them. Gandhiji, we have a time up to 12:15, right?
Sir, we can extend even, no problem. You can carry on.
Fine. And that way I can have a little more.
We have sufficient time.
That's good. Okay. So talking about smart green solutions, we have got blended cement, as I've already mentioned. Switch to blended cements. Then, as I said, that we need to involve more of natural lighting or that replaced kind of lighting as compared to the artificial light. So we have got some good quality concrete materials, unfortunately not available in India, but in some of the European countries it is being used, known as translucent concrete. I'll just put a couple of slides on that. We have got pollution eating concrete. There are certain concrete materials available now, not in India, but in some other countries, which can be put on the top of that building as a coat, and that particular product has that ability to absorb the pollutants. So I'll give some light on that. Aerated autoclave concrete, I have already given a detailed explanation, and it is 100% genuine green product rated by IGBC. Manufactured sand, switch from river sand to crushed aggregate sand, thereby preserving and conserving our river resources. Pervious concrete is a wonderful product that we have to put more focus on. I will be talking about geopolymer concrete as well. So what are the items that can be make use of as a additional material that can be mixed with ordinary Portland cement to make it green? First is fly ash from the thermal power plants, slag from steel industry, and then we have got silica fume, metakaolin, and rice husk, etc. That can be replaced to a good amount of percentage as per the BIS, and we can make our product greener. People generally confuse that, sir, if we go for blended cements, possibly we will not achieve the higher strengths. But it is not true. We have got structures like, this Petronas Tower in Kuala Lumpur, which was at one point in time the largest or the tallest tower in the world. They have used blended cements and still could produce a concrete of 100 megapascal plus. On the similar lines, in today's context, the tallest building in the world, Burj Khalifa, some of you might have visited over there. In this particular building, more than 2.5 lakhs cubic meters of concrete has been used, and the entire concrete has been used, is produced of the grade of M80, M90, M100 plus, and the entire concrete was made by using blending materials. So now the fallacy is that, and we have to get out of that myth that high strength structures or high strength concrete cannot be produced by using blended cements. So we have got standing, tall structures which are recognized by the world in front of us. Why I've been emphasizing upon reduction of OPC is mentioned in this particular slide. It is interesting to note that 7% of the world's total carbon dioxide emission is contributed by cement industry alone. So it's a very, very alarming, fact. 7% of total carbon dioxide emission in the world is contributed by cement industry alone on the global perspective. And 1 ton of OPC manufacturing, almost 0.9 tons of carbon dioxide is emitted in the environment. So just look at that quantum of carbon dioxide which is being emitted in the atmosphere because of production of every single ton of OPC. And let me give you another figure. In India, we have got a capacity of about 450 million tons per annum of cement production. Okay, and globally, we are about placed on the third ranking, where US and China are ahead of us. Just imagine the total amount of cement being manufactured every year, and the quantum of carbon dioxide is emitted every year with every ton of production. So the message here is that we cannot stop cement manufacturing, but definitely we can partially replace OPC with certain blending materials and thereby reduce the carbon dioxide emission in the environment. So this is the message through this slide. And the beauty is that after the blending with either slag or fly ash or by any rice husk or metakaolin or silica fume, the concrete performance or the concrete attributes also increases as compared to the typical ordinary Portland cement. So then we have got double advantage. Not only we are getting a green cement in place, at the same time we are getting a lot many benefits which possibly OPC does not give. So I will just describe one by one the overall strength which everyone is concerned about. So in case of blended cement, the overall strength is increased by almost 20-25%, up to 30%. The heat is reduced by 35%. As you know, in India, it's a hot climatic country. A lot of the temperature in the peak of the summer goes to as high as 48 to 50 degrees Celsius. So in such type of environmental conditions, if we are manufacturing concrete, so and overall that cement is OPC, so the heat of hydration is very, very large. So by using such blended cement, the heat of hydration can be significantly reduced by up to 35%, and thereby the cracks can be minimized on the structures. Concrete can be densified, concrete can be made watertight, and the most important parameter is that the blended cements have exhibited over the years far better resistance against sulfate, chloride, and alkali aggregate reaction, which are largely detrimental to the durability of the concrete. So let us have blended cement in place so that you have got a cement that can fight with sulfates, chlorides, and other alkali aggregate kind of reactions, which generally happens within the concrete in a much better, almost 60 to 90% better resistance and better fighting spirits. So that says it all. With the you can reduce not only carbon dioxide emission, at the same time 650 million tons per annum of solid waste in the form of fly ash can also be reduced. Now, in this slide, I have tried to show a corrosion map of India. As we all know, our coastal line stretches up to 7,000 kilometers, right? Starting from the Kutch in Gujarat, coming all the way down to the South India and going up all the way up to West Bengal. So this particular coastal line is stretching up to 7,000 kilometers. Okay. Now there are many states and innumerable number of districts and villages situated along and across these 7,000 kilometer long coastal line. Now, as we all know, that coastal line has typical, the salinity of the water is very high. We have got great amount of sulfates and chlorides in that particular salty water. So, if we construct our buildings along this coastal line, definitely we have to have a thoughtful consideration for selecting the right cement. So, what would be the right cement? Obviously, blended cement. Now, out of the blended cement, Portland slag cement has exhibited by experience a better resistance for fighting against chlorides and sulfates and alkali aggregate reaction. So that is very, very important and pertinent to know that if we happen to construct our buildings along these coastal line or the sea along the sea shores, we have to have a very thoughtful consideration on selection of the cement. In the past, we have observed through our many studies and research that those structures which were situated, on the seashore or the coastal line, like some important infrastructure projects like bridges and other buildings, and when they were constructed with ordinary Portland cement only and no blending was done, with a couple of years of performance, a lot of chloride has gone inside the concrete because of the poor cover and poor compaction also that might also have contributed, but the major culprit was the poor selection of the cement or the wrong selection of the cement, and the cement which was available within the concrete could not fight with sulfate and chlorides. The chloride and sulfate ingression took place over the years. It has corroded the steel, and as you know, when the steel starts corrosion effect, its volume enhances. As the volume enhances within the concrete, it becomes hollow from the core, and its structural strength is at stake or structural strength is challenged. Now, in this process, as the steel bar within the concrete expands, it exerts stresses on the ambient or the surrounding concrete. And since concrete is a rigid member, and when the stresses are getting exerted within it, what will happen? We'll have a lot of cracks started opening up, and it also affects the chain reaction. As the volume of steel increases, stresses develop on the concrete. Concrete opens up, a lot of structure cracks appear on the surface of the concrete, and more quantum of chlorides and sulfate goes into the concrete. Now that becomes detrimental to the health of the concrete, and as you can see in the pictures, a lot of spalling takes place, and entire stability or the structural strength of the structure becomes highly dangerous. In this particular pic, you can see the structure deterioration is taken so vigorously that the overall column size has almost reduced to half. Another picture you can see, the steel is now exposed, it is corroded, and it has spalled the concrete along it. So we need to have a right selection of the cement. So as I mentioned, all the blended cement, whether it is Portland Pozzolana or Portland Slag cement, they have wonderful benefits. Not only it gives a very good workability, but the density of mortar is also increased, strength is increased, and we have got better resistance for all the chemical aggressive contents. Now, as I mentioned, translucent concrete or the light transmitting concrete. It is actually not a structural concrete. It is only meant for load-bearing structures as a facade or like as a building block. The basic objective of translucent concrete is to permit the natural lighting within your space. This is the basic objective. Now, it is unfortunately not available in India because of the costing parameters, but those friends who are listening to me from the Europe or America, possibly they might have had come across translucent concrete somewhere or the other. So what is the basic composition of translucent concrete? It is very simple to make, not a very big rocket science. The only thing that we need to consider, the optical fibers are the main major element for this concrete. The density is about 2000 plus kg per cubic meters, and we have got about 90 to 95% of fine aggregates, and very small quantum of coarse aggregate is being used. So it is kept light in weight so that it can fulfill the purpose of as a facade or as a as a building block only. It's not meant for structural stability. It is not a structural member. So it can be used for green buildings because you can substantially reduce the artificial lighting. It gives a good aesthetic appeal to the building as well. Although the strength can go up to 50 megapascal, but as I mentioned, it is not meant for structural structures. Couple of pics, and the gentleman on the screen is an architect from Hungary, Mr. Aron Losonzi. He is the architect for inventing this particular translucent concrete. As you can see, he's holding one block in his hand. Light is thrown from the bottom, and you can see the light is coming all the way up to the top. That is how it looks like without transmitting the light. And once the light is thrown from one side, as you can see, one lady standing on one side. The natural light is coming from the back of her, and it is almost, you can see, 60 to 70% of the light is easily transmitted inside the hall. That is how it looks like. So, these are all blocks that are put one of the other, and on the similar way, entire facade can be created, or the entire wall can be created by using these blocks. So it has a good amount of water resistance. As I mentioned, the overall strength is 50 megapascal. Okay, and it has a good density because of the 90 to 95% of finer materials. Coarse aggregates are almost negligible. 4% is about optical fibers. 90 to 95% is your fine aggregate, and some binders and other chemicals that are used to make it composite material. Now, this picture gives you a fair idea. Almost 70, 80% of natural light is coming. So the message from this particular material is that we can reduce usage of natural lighting, at least during the daytime. Now, pollution eating cement is nothing but ordinary white cement, and wherein we add very small percentage of titanium oxide. So the titanium oxide becomes a kind of agitator, or it becomes a kind of catalyst that reacts with the white cement and make the cement in such a way that it breaks the chemistry of the pollutants. So which are the major pollutants? Suppose if I had painted the front elevation of a building with this particular pollution eating cement. Now, on this particular face of our building, or the top of the building, there will be continuous, attacks of nitrogen oxides, nitrogen trioxides, and various other, hazardous gases continuously attacking on the top of the surface. And over the period of time or over the years, the top or the front side of the building becomes shabby. A lot of, black spots and a lot of shabbiness appear on the top of the building. So what is the beauty of this particular titanium oxide? Within that particular cement, it works on the process of photocatalysis. What is photocatalysis? Photocatalysis is a chemical process wherein, in the presence of sun and in the presence of a little bit of moisture, this particular titanium oxide breaks the nitrogen oxides into nitrogen and oxides. And thereby, once it is broken, it can be easily washed away. It will not deposit on the top surface. So that is how, on this very concept, this particular pollution-eating cement is based on. In my previous organization, when I was in Bengaluru, I was working with Ital Cementi, and they have got a patent for this particular product. And again, coincidentally, it is not available in India because of very high pricing. But in the European countries like Italy, France, Spain, and other countries, this product is being used extensively. So this is the whole process in the presence of sunlight. The titanium oxide reacting with the cement and breaking the oxides and nitrogen separately, which can be easily washed or which can be easily cleaned up. So this is one of the hotel somewhere in France. As you can see, this building was painted with this particular product, and even after 10 years, as those who have visited Italy and France and other European countries, they have got a fascination for white buildings, but mostly in churches and all that, they keep the exterior facade as white. So in order to avoid the deposition of all these pollutants so generated within the atmosphere, this particular paint can be done, and by just a small washing, the entire pollutants will run away, or it can be cleaned up. So you can see, even for more than 10 years also, the whiteness of the building will remain as it is. A couple of more pictures. Now, very pertinent and important from Indian context, as we are concretizing our living spaces blatantly. And I really feel sorry also as a civil engineer. Whenever I go, I see concrete roads, concrete surfaces, a lot of concrete pavements wherever I can have a stance at. So, but on the same lines, we also have to educate the planners, the municipal engineers, and the consulting engineers, and more so the educators, like those who are in the engineering colleges, they are teaching their civil engineering students. I think there's a dire need now to encourage and educate on pervious concrete. Every second year, we keep listening, we keep hearing, we keep reading the news that so and so village or the town has completely gone out of water with the very onset of the summer. Why it happens? Because we are continuously extracting the groundwater by virtue of various bore wells and all that thing, and we are not giving any focus for the recharging it. Why? Because we have completely concretized our surfaces, our living areas, wherever we can have a look at, we find that concrete roads, concrete pavements, even the manhole covers are made up of thick concrete. Why there is a need? We need to encourage pervious concrete. Pervious concrete is nothing but a concrete which is made up of using more of coarse aggregate, less of fine aggregate, and some very good quality of admixtures that has, and cement obviously, which can hold all the materials. As you can see in the pictures, it is not rocket science to make. Anybody can produce pervious concrete. The basic objective, again, I would emphasize, to let 70 to 80% of the water go inside your ground and recharging the groundwater table. That is the basic objective of your pervious concrete. I think This is something that I always, talk about. I always think about, and I always, request the stakeholders to uh, pay proper attention on this particular element, that is pervious concrete. The beauty is that, as I said, 70 to 80% water goes down, and it will continue to discharge your groundwater table. So, what are the areas of application? Your pathways, footpaths, garden areas, parking areas, manhole covers, or wherever you find that any area where uh, heavy trafficable volumes are not there, where the heavy traffic is not supposed to pass through, that particular surface can be made up of pervious concrete. In continuation with the green building materials, as I mentioned earlier, autoclave aerated concrete block is a genuine green building material. Why? Because for producing that particular block, only 20% of the cement and almost 75% of fly ash is being used. Now, when the quantum of almost 75% replacement is with one material, that is fly ash, which is being procured from the industry waste, procured as an industry waste from thermal power plants. So you can very well imagine that it will qualify to a green building material. And again, as I said in the one slide where I have shown you the 8 major points for getting the green building credit, the one point that if you can recall is what is the recyclability of the product after its life cycle. So in that category also, AC block, once the building has completed its life cycle, once the building has been demolished, so wherever the AC block are being used, it can again be procured and it can be used as partial replacement towards coarse aggregate. So it has got a wonderful life cycle and recyclability. That is how it looks like. Light in weight, large in volumes. So since it is larger in volumes, so the quantity of that mortar along that particular blocks will be on a lower side. Eco-friendly, green product, very high fire resistance, very high thermal insulation, less number of joints, dimensionally accurate, unlike our typical red bricks, and it is available in different sizes by the manufacturers. Can be put into use for external and internal walls, for air-conditioned buildings and fire-rated buildings. So sand, make less use of river sand, more of manufactured sand. Why? Because with a continuous depletion of river sands, we are witnessing rivers are dying. If you just go through any environmental study on the climatic changes, you will be very sorry to know that in last decade or so, many rivers which used to flow in their full bloom some 5 years, 10 years, 15 years ago have completely become extinct. There is no water flowing through those rivers. Why? Because the reason is that because of the continuous extraction of sand from these rivers in all these years in huge quantities have completely murdered these rivers, and today they no longer exist. If you go to those rivers, possibly you might have visited some 10 years, 15 years ago, you might as well get a barren land instead of a flowing river. So that is a very, very worrisome picture. And the beauty is that now central government and many state governments are now making it mandatory to go for manufactured sand or the crushed stone aggregate sand. So what is that? It is nothing but the coarse aggregate, which is on the sieve, it is your 4.75 and millimeter and above. Now the same kind of coarse aggregate, 10 mm down, 20 mm down, aggregate can be crushed further in the same crusher units or maybe some specialized crusher units, and it can be brought within the 4.7 millimeter and below, and it can the sand so produced can be be used for your plastering or mortar or for the concrete purpose. Now, people may ask how it is all about performance. Performance wise, I myself have conducted a lot of concrete studies, and I found that in terms of strength, it is 20 to 25% more than typical reverse sand concrete. Workability is almost equivalent to reverse sand. Overall durability is high. Why? Because we found that the entire concrete, which has cement almost 12 to 15%, and almost 75 to 80% is constituted by aggregates, coarse aggregate plus fine aggregate. So the coarse aggregate and fine aggregate in totality about 70 to 75% now belong to the same family. So the larger chunk of your concrete mix is now belonging to the same family. Hence, the cohesivity and the strength, the workability is far more than a reverse sand produced concrete. Now, another very important point here I would like to mention is that, as if you have seen that the reverse sand, shape and texture, it is rounded in shape, it is spherical in shape. So the bonding between sand and the coarse aggregate is sometimes challenged, wherein here the crushed stone aggregate or the manufactured sand shape and texture is angular. You have got a lot of angles because it is crushed, so you have got angles. It's not in spherical, it is not circular in shape, it is spherical. Not it is spherical, it is angular, so a lot of angles are there. So when these M sand is being used in the concrete, we have got a very high amount of bonding between the aggregates. So when the bonding is high, the density is bound to be higher, and when the density is higher, obviously the strength goes up, which is why we get about 15 to 20% plus strength with the same amount of cement being used as compared to the reverse sand concrete. Apart from this crushed stone aggregate, now even the slag can also be crushed to the sieves of 4.75 millimeter down, and it can also be used as a slag sand. In some southern part of India, like when we talk of Karnataka, Tamil Nadu, Kerala, and Andhra Pradesh, slag sand is being used in totality or as a partial replacement to the M sand, and we are getting a very good quality of workability, strength, durability, and all such concrete parameters. I could mention one big manufacturer like JSW Cement, which is a major name in the southern part. They are one of the largest steel manufacturers also, and because a lot of slag is being produced, so they've started marketing this slag. So with this, with slag, which is essentially their waste material, they are selling it as coarse aggregate, they're selling it as fine aggregate, and also they're selling it as slag material also that can be partially replaced with ordinary Portland cement. So the thing is that the message here is that there are a lot of innovations are being taken up, and we need to have a focused approach how we can replace the typical traditional ways of construction materials by virtue of all these material which are available now. And aggregate from demolition waste and recycled concrete is also possible for the replacement of sand, reverse sand. That is how it looks like. Now, the second topic for the day is utilization of construction demolition waste for further usage in construction. As we all know, a lot of unauthorized constructions are being demolished. A lot of old structures which are no longer habitable from safety point of view are being demolished. Or we also come across certain concrete roads or certain infrastructure projects which no longer required by the government agencies are put for the demolition. Now, when such structures are demolished, a lot of concrete, a lot of debris is accumulated. Up till now, nobody has thought what is to be done for this kind of construction and demolition waste. But now, a lot of studies are being done. A BIS code is in place. central government is now quite focused, and they are also encouraging the state governments, and through the state governments, municipal bodies are being educated about best utilization of construction and demolition waste, so that in two ways we have advantage. First, we do not get unwanted material lying at one particular place and occupying the useful area of the town. Second, we do not get any hazards out of that. And third, we can preserve and conserve our traditional raw materials while designing a new project. So in these three ways, we can design our C&D waste management and reduce the burden on the municipality and encourage the conservation of materials. So the general study says that when a building is demolished, so we have got about 4% of concrete, about rock is about 4%, mixed hard materials and soil is about 18%, and likewise some building debris 10%, and soil is about 60 to 65%. So that is the whole quantum of different segregated materials. So whenever a building is demolished, the biggest challenge is that we have to segregate all the materials in such a way that we can get them, place them separately, and make use of them. Because when the building is demolished, we have got sand, we have got coarse aggregate, we have got bricks, we have got steel, we have got cement, we have got wooden, and everything mixed together. But the technique, or the idea is to get all the materials segregated so that they can be put into use in a much more technical manner. Once the materials are segregated, we get this kind of materials, as you can see in the picture. A lot of investment is to be done in C&D plants. For that, government has to incentivize and give a lot of tax holidays so that they can invest their money. They can have that system in place wherein right from collection up to segregation up to final finishing of the product can take place. But that requires scaling up of the quantity, as well as government incentivization is absolutely must. Without that, this particular theme will not get any kind of encouragement. Yeah. Once this material is segregated, and we can make use for the recycled material can be made use for making paver blocks, concrete blocks, or this kind of precast structures. As you can see, you might have seen a lot of such kind of paver blocks and concrete blocks that can be used as a brick, and these are the separator blocks. Talking about India, about 530 million tons of C&D waste is generated every year. This is the very latest study I am referring to. 530 million tons per annum of C&D waste in India. So that's quite huge actually. Just imagine if out of 530 million ton, if we can make use of at least 50% towards reuse or recycling, I think we can conserve our natural resources by the same amount. So this is the need of the hour. Second point is that there is an opportunity to recycle inert waste also, inert waste for the use in construction. And then third is, we have got currently about 2 plants are in operation in Delhi, but there is a need to have many more such plants across the geography of India. Talking about the breakup and composition of waste, we have got all kinds of waste generated, out of which 55% waste is towards construction and demolition, and almost 45% is towards domestic and metallurgical, agriculture, textile, etc., etc. So the larger quantum is contributed by construction and demolition waste out of the total waste generated in India. So what are the challenges for C&D waste management? First is sustainable business model. The government has to ensure that they get enough C&D waste for recycling and processing. Second point, government need to incentivize and give tax holidays. There is a greater amount of awareness to be developed in the public domain so that the developers, builders, and that consulting engineers, they can adopt and accept. It has to be made a part of Swachh Bharat program. We have got many countries across the globe which have already adopted. And I was told that in Germany and in Japan, almost 80 to 90% of CND waste is being utilized for further construction. 80 to 90%, which is phenomenal. Meaning thereby is that in such countries, or we can say such advanced countries, they have developed a model, they have devised the techniques, the government is supporting, and there's a good amount of awareness in the stakeholders so that they can use these materials for further constructions and thereby reducing the burden on the country. So there has to be good amount of awareness to be spread for CND concept among all that stakeholders. Government has to encourage, and it has to be made mandatory for the at least for the government department works. The technology transfer has to be very smooth, because we have got this live examples available from other advanced countries. In India also, it started in a very small manner, but it needs to be expanded. Codal specification has to be properly provided. Approvals and certification, product research from CND waste. So a lot of research is being done. It is not that there's no work done. So many researchers are doing their project on CND waste, and I'm sure with more knowledge gain and with more experience, we'll have some good codal specifications in place. Government will be more encouraged to adopt these technologies, and stakeholders will be more educated and aware. Just reference I have taken from one of the studies, how concrete parameters differ from the traditional concrete. Traditional concrete means the concrete which is made with non-recycled, that is original materials. And on the right hand side, you can see C35R. R means the concrete which is made by using cement. Quantity is same, but the aggregates, that's coarse aggregate and fine aggregate, have been replaced from natural coarse and sand aggregates. Okay, so in C35R, as you can see, with the same amount of cement, the density is almost same. There is not a significant difference. Density of fresh concrete with natural resources is 2484. With recycled aggregate concrete, the density is 2424. So hardly about 60, which is insignificant. Now, density after 28 days, there is some difference actually, because as the concrete solidifies, the water goes up, evaporates. So the density, is reduced. In case of natural resource concrete, it is about 2436, and it is reduced by about 50-60 kg. In case of recycled aggregate. Why? Because the recycled aggregates, whether it is coarse aggregate or whether it is sand, they tend to absorb more water, because their exterior surfaces or the exteriors of these aggregates is already coated with some amount of sand. So in the process itself, the coating is being removed by adopting certain chemical processes also. So that is a basic, the idea of presenting this screen is to just let you know this, though there is some, differences in densities, both in fresh as well as in, hardened state, but it is not significant. I would like to show this. That is how the plant looks like. This is integrated C&D waste plant in Goa. I'll just summarize this thing. Now, what is the practical experience during casting? So 20 kg less cement was used to get the same strength. So you're saving on cement also. workability was fantastic, finishing and everything was quite okay. A curing membrane was used to prevent cracks, and no presence of bleeding or cracks were observed during the pouring, finishing for the first 24 hours. So, 9 months after the pouring, no cracks were observed in the concrete slab that could be attributed to the aggregates. So, the gist is that not only we are reducing the cement quantum, but we are getting a good workability, good pumpability. After the curing, we do not observe any kind of cracks also. So summary is that for CNT waste, despite the extremely challenging materials, the variation in the physical, mechanical, and chemical properties was reasonably stable. It mostly conforms to IS 383, which stands for coarse and fine aggregates. The grading properties were found to be sufficient quality. So that is very important when a proper concrete mix design is applied, because you need to have a proper grading also while designing a mix. And to account for the variation in the water absorption, the lot-wise water absorption can be monitored during material acceptance to make the necessary adjustments to the total water content in the mix. Now, as we know, that consistency is a challenge, because one lot of material is coming from one particular building, other lot of material is coming from some other building. So in that particular event, we need to homogenize the materials, and we need to have a very close check on the water requirements for that concrete mix. Now, I would like to conclude on this thing. The documented results have shown that recycled concrete aggregate, that is sand, can be produced from a good quality feedstock by following well-controlled production process. And the consistency quality gives confidence that recycled concrete aggregate replacement up to 40% can be achieved without adversely affecting quality as confirmed by the international experience. So we have to go by this experience, which says that 40% of CND waste recycled aggregates can be used as a partial replacement for producing a good quality concrete. Geopolymer is going to now. I would like to talk a little more on geopolymer concrete. It is nothing but thinking beyond ordinary cement. So it is going to be the cement of the future, and it is 100% green building material. Why? Because with this polymerization chemistry, we are not using any limestone, we are not using any cement, and still we are getting cementing material. So this is all about geopolymer. We are using almost 50 to 60% of the fly ash plus some activators in the form of sodium hydroxide and calcium hydroxides. They react with each other chemically, form a gel at a very elevated temperature, and after the gelification and geopolymerization, the material is so produced, and we add, obviously we add aggregates also, normal aggregates. So the gel so produced has that ability to bind the aggregates in such a way that the matrix so becomes has good concreting values, and it is found to be stronger than a traditional cement made concrete. So geopolymer is going to be concrete of the future. I think we will have more discussion. It can be taken as a separate topic also. So the only challenge with the geopolymer concrete, which is still in research stage in most of the areas, the biggest challenge is that workability is still being worked out. There are workability challenges, and the second challenge is that we need to give a temperature of about 70 degrees Celsius to produce this particular concrete. And the third challenge is that we have to transport the chemicals to which actually work as activators with fly ash. So these are a couple of challenges, but I'm sure the researchers and the scientists who are working on this geopolymer concrete will resolve these challenges, and in very few years from now, we will have geopolymer concrete happening in India. So with this, I just conclude my session because I think I have already exceeded the time limit. You can see this is a one undersea route, and there is a tunnel undersea which connects France to Britain. 100% this particular concrete was produced by using blending material. This is one snap. I thought it is quite relevant to show. This is Lotus Temple in Italy. Beautiful structure, a wonderful civil engineering marvel. And again, it's 100% blending material concrete. This is one, largest bridge, hanging bridge in China. This is Petronas Tower, Burj Khalifa, as I mentioned earlier also. So these are all structures made using green, sustainable, innovative materials, wherein all such parameters which contribute to the environment, to the society, and to the overall economy of the nation into place. And after that consideration, they have been designed and still existing for many, many decades. So with this thing, I would like to say thanks to everyone who have listened to my this session. So let us make a sustainable and greener world. With this, I conclude my session and over to Gadiji.
Thank you, sir, for your nice and informative and very insightful talk on the green material. We all come across so many new green materials today, and definitely it will help our, the participant. Those are from having the civil engineering background. Few are the graduating engineers. Some are the field engineers. Will definitely take advantage of these uh, by knowing these green materials, and definitely they are going to explore more on this. So I, on behalf of all participants, we are very thankful for this nice and wonderful presentation. If you permit, I will take few questions, sir, because participants are very much waiting for their queries.
Yeah.
So, okay, sir. So the first question I would like to take is asking. Mr. Vijay Sharma is asking, sir, please explain cost effectiveness in use of green building material in lieu of conventional building material.
Okay, fine. As we all know that green building materials are costly to begin with. Okay, but when we consider its life cycle, okay, so over the years the entire cost is getting recovered. So initially speaking, initial cost may be higher, a little higher, not very significantly higher, but over a period of time, because of the its life cycle approach and the advantages that it brings out, it will become cheaper comparatively.
Okay. Right. So the next question is from Mr. Mohammad Rafiq. I think he's from outside India. He's asking about blended cement commercial benefit is going to cement industry only. Why not the industry can reduce blended cement cost towards more uses of blended cement?
Yeah, cost-wise speaking, blended cements are anyway cheaper to traditional ordinary Portland cement by couple of rupees. Okay, we all know that, but looking into a larger benefit, I think the kind of durability and the kind of strength that we get, because blended cement has that beauty of uh, having a larger strength beyond up to 1 year also. So the strength continues to keep on increasing. So we have to look at and focus at all those parameters instead of the financial gains, and at the same time the kind of environmental protection that we are producing, providing because of this utilization of fly ash and slag from other industries is also has to be considered. So commercially speaking, it is definitely a cheaper option, but at the same time, benefit wise, it gives a larger benefit to the customer.
Okay. So then another question is from Mr. Milind Gupta. He is asking, can partition wall be constructed of AAC, aerated autoclave concrete block?
Yes, AAC blocks are primarily meant for giving walls only. It can be made for internal as well as external walls. I mentioned also in this my presentation. Internal as well as external, both walls can be constructed by AAC blocks.
Yes. I think the speaker may definitely get satisfied with this his reply, right? Then another question is from Praveena. can you please let us know exemplary illustration of green building? I think you already have discussed about the
I
green building.
think
You can add anything more on this as per her queries. Okay.
most of the illustrations I've already given, and
Yeah.
if someone has the chance, they can visit already listed green building structures in India. There are very many. Okay.
Hmm.
The headquarter of Indian Green Building Council at Hyderabad itself is India's first green building, and
Okay.
those who are quite interested in green building rating and structures, etc., they can enroll themselves with IGBC. It is available on their website. They can become accredited professionals also, AP,
Mhm.
IGBC, and they can have the opportunity to visit, to get the list of all those IGBC structures, and they can understand and improve their learnings on this.
Okay, thank you, sir. Then the another question is from Mr. Milind Gupta. Is there any material to replace coarse aggregate in green building?
Yeah, I mentioned that in my
Yeah.
discussion. Slag, which is being produced by a couple of steel manufacturers, it is being sold in three different ways. First, it is ground to the fine powder, and it is replaced for the OPC. Okay. Second one is it is brought to 4.75 millimeter down aggregate, and it is being used as a replacement of reverse side. Right? And third one, it is the sieve size is kept 4.75 millimeter and above, so it can be used as a coarse aggregate. So coarse aggregate has the replacement in the form of slags.
Then again,
And
further, he's asking about any
uh,
example of non-toxic paint used in green building.
non-toxic
Oh.
paint. Yeah, there are. When you refer to the data sheet of paint manufacturers, now every one of them has started claiming it does not have any hazardous element, or it is non-toxic. So there are very many manufacturers. It's not a big deal.
Okay.
Yeah.
Sir, then another question is from Mrs. Shikha Pandey. In pervious concrete, how can we stop clogging?
Yeah, this is one challenge that which is being often faced by pervious concrete application. So we need to have continuous cleaning of the top of these pavements which are constructed by using pervious concrete. So the top area has to be continuously cleaned up continuously.
Okay.
Yeah.
Okay. Sir, one more suggestion, or one can assume a demand from the participant, that is Milind Gupta. He's asking about how to calculate the rate of the green building, or can we arrange a separate session for the rate for rating the green building using LEED and IGBC. So
Uh,
definitely we will take this thing as a good suggestion for the future activity, because this is a separate area to be discussed, and has to be elaborated, because it has a
yeah,
so many dimension,
yeah,
lead and
very correct.
IGBC criteria, right?
Yeah, yeah.
We
Yes.
will think about it later on.
It's quite an exhaustive subject, and definitely a
Yes,
separate session can
yes,
be planned out on that. Yeah.
yes. Then Dr. DK Shukla, his faculty in our department, is asking about manufacturers and required more water cement ratio, how to handle it.
Yeah, I mentioned that in couple of cases we do face workability challenges, right?
Right.
When the concrete is being designed by using manufactured sand, we need to understand it why it happens. As I
Mhm.
mentioned categorically, that the shape of these manufactured sand is angular in nature, right? So we'll have there will be a interlocking between the aggregates. So in one way, the interlocking is helping us in getting better strength and better density, but at the same time, the flowability, which otherwise would have been possible by the rounded or spherical shape of sand, is missing, right? So the workability is definitely challenged. In that case, water need not to be increased, but some there are good quality plasticizers are available. So that plasticizers, a very small amount can be added with water into the concrete matrix, and we can improve the workability. So water demand is definitely seems to be more, but instead of increasing the water, some plasticizers can be added.
Okay, okay, thank you, sir. Then the other question is from Manash Boi. What is the age of green material? as per carbon dating?
Well, it is not documented as of now, but one thing is for sure that in our real life also, when we look at historical monuments, they were constructed almost 400, 500, or even more years before, are still existing and standing tall as a testimony, right? So they were largely green in their construction concept. So in the same way, when we are, constructing a building with green building materials, obviously the lives are going to be more than the traditional buildings. So it is not documented as to how much will be its lives, but it will be definitely more than the traditional non-green buildings.
Okay, thank you. I think the same question has been asked by another participant also, Sai Krishna, that about the durability of recycled aggregate. So it is related with the age or durability of the green material, I think. Right, sir.
Yeah.
So then one more question. One of our faculty member, Dr. D.K. Shukla, wants to ask. I
Yeah.
request him to please unmute and please ask the question to sir. Shukla, sir.
Thank you, sir. Thank you very much for giving me opportunity. First, I want to thank you for exhaustive lecture, for a very nice lecture you have delivered,
Thank you,
informative
sir.
one.
Thank you, sir.
And basically, I am interested to know that even as per the permissible limit of plasticizer, as per
Mhm.
IS code, if we design and we use M sand, even then the maximum limit 2.5%, 3%, we have gone. And we have made a pumpable concrete and using M sand. Even then, up to 60% or 70%, the mix was just like a dry, or the slump was nothing. So, any locally or any material which you would like to suggest so that we can improve the workability or the water absorption with the M sand is having a problem. Despite being, we have initially designed a pumpable concrete, we carry a fluidable concrete, and by replacing with the natural sand with the manufactured sand, it created problems. Some material which could do not absorb the water and part as a sand, work as a sand. Something could be suggested from your side if you have any suggestion for that.
Okay, Dr. Shukla, may I know what was the percentage replacement of recycled aggregates?
Recycle, not aggregate. Yeah, I'm talking about M sand, manufactured
Okay,
sand.
okay, manufacturing. Yeah.
And
What was the
the
percentage?
percentage I have gone up to 80%.
80% was the
Manufactured sand, and 20% natural sand.
nitrogen. I think the one correction that can be start since it's a pumpable concrete. In that case, it can be made to 50-50, right, to begin with, right? And the second suggestion I would like to give you is that you can go for some good quality plasticizers also, super plasticizers, which are anyway available in the market. Okay,
Okay.
and you can have some pre-mixed trials also before
Yeah.
making that concrete. So what is your since as I know it's a pumpable concrete, so that slump has to be 110 to 120, right?
Yeah.
I
Yeah.
mean, so to achieve that, I think you have to incorporate some more quantum of river sand so as to have a kind of a ball bearing effect, right? And at the same time, some good quality super plasticizer. I think with this combination and some a little bit of trials, you can achieve your targeted slump requirement.
Okay, sir. Okay. So some material is not suggested from your side. Any
Uh,
we
Commercially, I cannot name any company, but when you go to the market, there are good quality admixtures, good quality
okay.
construction chemical companies. Okay,
Okay. Okay.
and they can definitely provide you. It's not a big deal actually. Had it
Okay.
been a non-pumpable concrete, I would have advised you to continue with the 80% replacement, right,
Okay.
and
Okay.
use some plasticizer. But since it's a pumpable concrete, so I understand that for the pumpable concrete, and what is the height where you are pumping this concrete?
No, sir. Actually, I was more interested to know any material which do not absorb water and we can replace M sand by 100%. I have prepared a pumpable concrete to make a normal concreting. We have make a zero slump is maximum. We have initially we have prepared a concrete like this and
Mm-hmm.
added the M sand so that we can get the adequate workability at the end when we replace 80 to 90, even 100% M
Okay.
sand. And I was unable to do that. So some
Uh-huh.
material is to be added despite being highest super plasticizer maximum limit I have gone. We
Mm-hmm.
did an exercise for that. So I was interested to know any some
Uh-huh.
material which could be suggested apart from super plasticizer, some replacement of sand actually.
Okay. See, if you want to continue with this percentage of M-sand, but still you may have to use some silica fume to improve its
Okay. Okay.
workability. Silica fume,
Okay.
as we know, it is 100 times finer than a
Yeah, yeah.
cement
Yeah, yeah.
particle, right? So
Okay.
it will induce good amount of workability and good amount of ball wearing effect. So the
Okay.
movability or the workability will improve for sure. And I think a
Okay.
very small percentage of silica fume, which is
Okay.
available in the market,
Yeah, yeah.
alcofine or silica fume. There are so many
Yes, yes.
manufacturers who are providing. So I think you can go for 1 or 2% kind of silica fume. Okay, that
Okay.
can be added, and it can be trialed with some super plasticizer. So still with
Okay.
80% also, you will have some significant improvement in your pumpability with MSAT. I think
Thank
we
you,
need
sir.
to have some
Thank
trial and error. Yeah, and separately
Yes.
also, you may call me separately. I
Yes,
can
sir.
give you some more ideas on that.
Yes, sir. Thank you, sir. Thank you. Thank you, sir.
Right.
Sir, we will take two, three more questions. Still, the participant is asking. The question is from Ibrahim Al Labadi. He is telling that can the ash resulted from incineration of pollutants be used in the manufacturing of this concrete?
From incineration. So from
Yeah,
incineration of what products?
uh, is mentioned that I mean, he's talking about the all the waste material that has been put in the incineration, right?
Mhm.
Then can it be used
See,
in the concrete?
See, up till now, the kind of studies that have that are in place for the cement replacement. Okay, we have got rice husk ash, correct? Right.
Yes.
It can be put into use. We have got fly ash, as
Hmm.
we all know, and
Hmm.
but apart from that, we have to have a very specific as to what kind of product is being incinerated.
Hmm.
If it is a medical waste, possibly we cannot go ahead with it without any proper studies. Okay, we
Hmm.
need to have the
It
proper idea. Yeah,
it requires the to understand first its chemical properties,
obviously,
right? Then
obviously.
only we can use in the
Yeah.
concrete.
But
Okay.
rice husk and fly ash is a known fact. Anybody can use it.
Yes.
And
Yes. Yes.
in fact, the medical that municipal waste
Hmm.
from the larger cities is being collected. It is put into a shape of bags, etc. It is dried
Hmm.
up, and then it is also being supplied to cement or steel manufacturers.
Yes.
So it
Yes.
can replace by 0.5 to 1% of the total fuel requirement. But it's a replacement of fuel requirement, but not as
Yeah.
a fly ash replacement. Yeah.
Yes. Yes. I understand. Then another question is from Dr. Suchit Reddy. He is asking, can you suggest life cycle inventory data availability in India related to embodied carbon and energy values?
I think it is quite available in public domain also. We can refer a couple of websites. So the EB values of different materials is available, and different countries have given their own values. So the kind of values that I had presented is basically average of a couple of countries figures actually. So it is available on the site. One can Google and get the information.
Okay. Then the second last question I can say is and this question is asked by Ayush Kumar. Does the embodied energy values for material vary as per location of uses?
The embodied energy, yeah, definitely it varies from one place to another because I told you that embodied energy of any building material is the sum total of the energy which has gone to extract from the mines to manufacturing process, the energy that has gone to manufacturing process, then the energy that has gone to transport that finished product, and then from that stage all the way up to the final customer. So energy required in all these 4 5 major processes is the total of EBE for that particular product. So one product may have different EBE in one place, may be different for different country. So, but the variations may not be very large, but definitely variations are going to be there. So we can very well understand from our common sense also. For example, suppose if I am using an outdated technology to extract limestone, there will be more induced energy gone into it, right? And if suppose I am sitting in an advanced country and I have to extract limestone, I've got some very high quality equipments. Energy gone to procure the same quantity of limestone will be less, right? So that will make the difference between EBE for the same product at two different locations.
Okay. Sir, this is the last question from
Okay.
Mr. Rajesh Agarwal. In crushed sand, the major challenge is to control the dust in it, which is not at all controllable in the manufacturing side. That's the way one can't be more confident every time. How to cope up with this?
Can you just repeat the question? What was the first line? Actually, I missed
So in crushed sand, the major challenge is to control the dust,
it.
which is not at all controllable in the manufacturing side.
Mhm.
So how to cope up with this?
See, in the provisions also, the dust is a certain percentage of dust is allowed. It's not a big deal, but the effort should be to minimize the dust content because ultimately it improves the water demand for the concrete. Because the more will be the dust, more amount of water will be required to coat around that particular smaller tiny particles. So dust has to be on the lower side. But I agree, dust cannot be controlled, but it can be like by some way if we can just filter it out before using in the large mass concrete, that is better. It can be
Okay,
sieved. It
so
can be sieved so that the fraction on 150 micron can be minimized. Fraction on the 150 micron can be minimized.
okay, so I think the we have taken the sufficient number of queries. If any participant have any more queries, you can please share your queries through the in the WhatsApp group, or you can share through the mail also, right? Uh, it is my duty to pay the vote of thanks. Uh, um, uh, Ashish sir, it was indeed a pleasure listening to your articulate presentation, right?
Thank you
On
very much,
behalf
sir.
of Civil Engineering Department of JP University of Engineering and Technology, Guna, I would like to take privilege to express our sincere gratitude to you. I am
So
happy to
nice.
mention that such large participation of more than 600 numbers would not have taken place without the support and suggestion of our colleagues, students, and alumni. My heartfelt regard to all of you for your unconditional support. As a team, we also take this opportunity to thank our management, Honorable Vice Chancellor, Dean, and Registrar for motivating us to initiate and accomplish this international webinar. I am also thankful to our IT department, led by Mr. Vikas Dikshit, for arranging live telecast for all the panelists and participants from India and abroad. I would like to mention that participation have been made from the country like USA, Canada, UK, UAE, Ghana, Indonesia, Singapore, Malaysia, Nigeria, Uzbekistan, Afghanistan, Nepal, and so many other countries also. It is really appreciable to boost ourselves for future organization of such event. We are again very thankful to all of them for participating in such a large number. So as a concluding remark, I would like to mention for the participant that due to huge response of the participation, the processing of certificate would require a week time. So I request you all to wait for a week so that you can get the certificate on time and in a correct manner. Uh, That certificate will be shared to you through the mail and WhatsApp, uh, through both the means. Now I'm going to share the feedback link. I request you all to please fill it correctly, because on the basis of this, your entry, the correctness of the certificate will depend. So thank you, sir, once again, and I thank you all the participant also for participating in a huge number. Thank you all. Thank you, sir. Participants, please check the feedback link in the chat box of YouTube streaming link. Right, you will get the feedback link. I request you all to fill it properly in all correct manner. Thank you, sir. Thank you, Ashish sir. We'll definitely have another session regarding the lead and other IGBC grading of the green building, and we'll definitely wish to hear you in future also about further advancement of the green material. Thank you, sir. Thank you, participant. Thank you, colleagues.